In today's lesson, we're preparing ourselves to move on to probability. And what we're learning today is what to do in certain probability problems that could be a little bit more challenging. So, for example, let's say that somebody comes up to you and says, I bought a lottery ticket. What are the chances that I'm going to win the lottery, or what's the probability I'm going to win the lottery? You'll actually be able to answer that question by the end of today's lesson. Okay, and so why do we have to do this prep work? Is because think about probability. Probability is you're going to take the fraction, the total number of successes. So in other words, you take how many possibilities there are for what you're wanting to happen, and you take that total and you put it over the total number of possibilities, how many total things could happen. All right, so finding these numbers in certain types of probability problems is actually pretty difficult, and so that is what today is about. And so today we are learning about how to find these numbers, right? So that's why it's called all the possibilities, okay? And these are also called counting problems, is because you have two options when it comes to problems like this. You can, number one, simply list out all of the possible things, all of the possibilities, and then count. Or you can use some of these shortcuts that we talk about and be able to do it as well. All right. And so one of them you have actually already talked about. All right. And so we'll cross that bridge when we get there. All right. So there's actually two different types of problems that you will encounter that are counting problems, and the way that you do them will be different depending on the type of problem we have. Okay. So the first type of problem is the one that you actually learned about Friday into Monday. Okay. And so with that type of problem, if you'll read along with me, it says, this is a situation number one. And it's whenever we have separate categories of things, so separate categories of things, and we want to choose one item from each list. And when you're choosing, the choices that you make have to be independent of each other. So like what you choose from one category cannot affect what you choose for the other. And when this happens, you have two options. If you're trying to figure out how many total possibilities there are for kind of your choices that you make, you can either make an organized list or a tree, which you had seen in other videos, or you can use that handy dandy fundamental counting principle to find the number of choices. So that's actually the first one we're going to talk about, is the fundamental counting principle. All right. So to give you an example of something where you would use that is, let's say for this probably would apply more so to the ladies that may have to consider this, but it can apply to everybody. But let's say that you have so many shirts and so many pants and so many shoes that you can wear. And usually you only wear, well, it kind of depends, but let's say that you're going to wear one shirt, one pair of pants, and one pair of shoes, and that would make an outfit. Well, what if you were trying to figure out how many different outfits you could make with that many shirts, that many pants, and that many shoes? That would be a fundamental counting principle problem, because you're choosing one from each category, the categories being shirts, pants, and then shoes. And you're trying to figure out how many possibilities. So that would be an example of the fundamental counting principle problem. Okay, so let us look at another problem that would be like that. All right. And actually, before we do that, this is just kind of reiterate what I talked about. So if you figure out it's one of these problems, and I just realized I spelled principle wrong, so please forgive me. In this case, it says a detailed way to count the number of possibilities is you can either make an organized list or a tree of all the possibilities, and then you just count them. So that's the way that we used to do it when we were like in middle school or elementary school, is we'd list out all the possibilities and just count. Or now you have a shortcut. So an easier method is to use the fundamental counting principle, or for short, we'll put FCP. So in the fundamental counting principle, all you have to do is just count the number of possibilities there are in each of the separate categories, and then you just simply multiply them together. So you had practiced that, okay? So I'm going to show you at least maybe one example of how to do that, all right? So let's say that there's a booth that sells candy apples, and you can choose one thing from each of the options here. So you can either choose to get a red or a green apple. You can choose to get a coating of either candy, marshmallow, or caramel. And then on top of that, you can have it put, like have them put nuts or sprinkles on top. Okay. And so you have two options. If you were trying to figure out how many different varieties of these candy apples you can make, you could sit there and actually list out all of your possibilities. Okay. So I'll kind of show you and remind you of how that works. So one way to do it is you can make a tree. So to make a tree, remember, you start with a little dot to represent the apples in general, and then you start listing out your options. So from the beginning, you can either choose to have a red apple as the base or a green. And then from there, you can have it dipped into some type of coating. And so if you get the red apple, you can either get one of three types of coatings. You can get candy, you can get it dipped in marshmallow or caramel. So I'll put that for candy, and then I'll put CAR for caramel. Okay, and then it's the same thing with green. If you get the green apple as your base, you can get candy, you can get marshmallow, or you can get caramel. Okay, and then from there, you have, after you get it dipped in whichever coating, you have kind of two options from there. So if you get it dipped in the candy, you can either from there get nuts or sprinkles on top. If it's dipped in the marshmallow, same thing. You could get nuts or sprinkles. And then it's the same kind of thing all the way down the line. All right. And so the way that you kind of read this to figure out how many total possibilities there are is you just count. So I could get a red apple with candy and then nuts. So that's one possibility. I could get a red apple with candy and sprinkles. That's another possibility. So I can just list out the possibility number on the side. I could get red marshmallow and nuts. So that's the third possibility. Red marshmallow sprinkles. And then you could keep going. So pretty much at the end of each line is a separate possibility. So I could just keep numbering all the way down the line. So if you counted them, there would be 12 in all. Okay. Another way that you could do this is you could just list them out like I did for you. Okay. So if you actually listed them out, it's kind of the same thing as the tree. You could just count and see how many there are. Okay. Which you can notice the more possibilities I add, the more time consuming this would be. And so that's the reason why we have this handy dandy fundamental counting principle. Instead of actually having to list them out, all you'd have to do is count how many possibilities there are in each category. So if you remember, there was 2 in the kind of apple you can get. You can either get red or green, so there's 2 possibilities there. There are 3 different coatings that you could get, and then there were 2 different toppings. And so from there, you just multiply them. Multiply 2 times 3 times 2, and then you have your answer instead of having to actually list them out. All right. And so that is kind of a reminder of how fundamental counting principle works. So that's situation number 1. So that's if you have different categories that you're choosing from and you're picking one from each category. All right. So the other situation that we can encounter, is what if instead of trying to figure out, or you have different categories and you're picking one from each, what if you're trying to figure out how many different ways there are to pull like a small group, like if I'm looking at you guys as a class, let's say that I want to pick a certain number of my students to help me with something. Okay. If that's the case, then that's actually the situation number 2. All right. So read along with me. Situation number 2 says when we need to choose a small group, or when you're choosing a small group, that's called a subset because it's part of a set. Okay. So when you are choosing a small group out of a larger group, then you have to actually use a different way of counting. So you will not be able to do the fundamental counting principle. Okay, there is an exception, but we will talk about that later. All right, so you will have to use a different method of counting. So to find the answer in that case, if you're choosing a small group of people or things from a larger group, you actually have to either do it as what's called a permutation or a combination. All right. So it can actually split off into 2 different things that you could have to do. All right. And it's either going to be a permutation or a combination. It cannot be both. Okay. And you'll find out why in a second. All right. So how do you know if it's going to be a permutation or a combination? Well, I'm going to give you an example that should hopefully clear it up. So a second ago, I gave you an example of, let's say that we are back in class. So let's say that it's a normal day. Can't wait to see all of your beautiful faces again. I miss you dearly. Okay. So let's say that I'm going to pick some students from my class to help me with something. Okay. There are 2 different situations that could happen from that. All right. And let's say that I'm going to pick 3 students out of class. All right. So I'm going to pick 3 of you. All right. So let's say in the first scenario, so this is situation number 1. Let's say that I'm going to pick those 3 students. So pick 3 to help me. How could I have you help me? Let's say that I'm going to have you deliver something to the office. So I'm going to pick 3 students to deliver something to the office. And maybe it's really heavy, so that's why I need 3 of you. Okay. All right. So that's situation number 1. Another situation that I could have, and this one would be one you probably prefer, but let's say that I'm still going to pick 3 of you, but this time the first student that I choose, I'm going to give $100. So I know you guys would prefer this option, right? So I give $100 to the first student that I choose. So let's say I'm going to use my popsicle sticks and randomly choose. So then the second student that I choose, I'm going to give $50. So they don't get as much, but they still get money. So that's not so bad. And then let's say the third student, because remember I'm picking 3 of you. The third student that I choose, I'm going to give $25. Okay, so again, not as much, but it's still money, so you should be hopefully grateful, right? So those are definitely different situations, and let me explain why those situations are different, all right? And this is actually how you're going to know whether something is a permutation or a combination. All right. Notice it is the situation number 2 because I am pulling out a small group out of a larger group of you, right? Because there's more than just 3 students in your class. All right. So it would be a situation number 2, but what's the difference? Well, if you keep reading, so if you read beside permutation, it says permutations are when the order of your choices makes different answers. So if you were to actually list out the different possibilities here, and if I accidentally switched up, for instance, you notice I'm picking the 3 students. If I actually accidentally mixed up the order that I chose the students, think about which situation it would make a difference in. Okay, that's the one that's a permutation. All right. And then if you read beside combinations, it says when the order of the choices does not matter. So in that case, with combinations, mixing up the order wouldn't really matter because it's not going to give us different possibilities. All right. So think about these two situations and then figure out which one you'd have to do as a permutation and then which one you'd have to do as a combination. So hopefully you figured out that situation number 2 here, this second example I gave you, that would actually be your permutation problem. Okay. So you'd have to do this one like a permutation. All right. And then situation number 1, or the first example I gave you, would be your combination. Okay. And so just keep that in mind. And then in a little bit, I'll come back to this problem and then I will show you how you can actually figure it out. Okay. We'll have to put a set number of students to class, but we will talk about how that works. All right. So let's move on, and we will be doing these with a calculator or Desmos. And if you do not have that at home, no worries. I will show you what to do if you don't have it, okay, so that you can still participate and learn, which is important. All right, so we're going to do a couple other examples before we actually talk about how to figure out how many possibilities there would be. And by the way, because I forgot to kind of talk about this, the main question that we would be asking here is how many different ways could I pull those 3 students out of my class of however many students we have, okay? So that's the main question here, all right? So let's do another example. So in this one, it says you've got 5 friends in a club and they're running for president and vice president of the club, okay? So there's only going to be 1 president and 1 vice president there. It says how many different ways can they be selected as president and vice president? So I want you to think about the type of problem this is, and then we'll calculate our answer by drawing a chart, and then later we'll talk about how to use the calculator or Desmos to figure that out. All right. So think about it. Is this the situation number 1? Do we have different categories and we're picking 1 from each? Or is this one where you're picking a small group from a larger group? And hopefully you realize we're picking a president and a vice president out of the 5 friends. So how many people is that out of how many people? Notice this is a situation number 2 because we're picking 2 people, president and vice president, out of the 5 friends. So this is actually a situation number 2. Okay, and so from there, remember, you have to decide, is this one of those problems where you have to where rearrange the order that you choose the people matters or not? So the first person you choose, think about what that's going to be. The first person would technically be president, right? And then the second person would be vice president. And so if I accidentally switch up who I pick out first or second, that would give me a different answer. So that would mean that this would be a permutation because the order that I choose the friends matters. Because if I, again, accidentally switch up who I have picked first versus who I picked second, that would give me different possibilities. So this is actually a permutation, all right? So to figure out, so again, we'll come back to this problem in a second. So to figure out how many different possibilities there would be for president and vice president out of those 5 friends, one way to do it would be like we did a second ago, where we actually list out all the possibilities. So we don't really have names, so we're going to write the friends as like a number. So we have friend number 1, friend number 2, friend number 3, 4, and 5, because there's 5 of them. So if I was starting to list out all these possibilities, I could say, okay, well, I could pick out friend number 1, and they would be president, and then I could say friend number 2 would be vice president. Or what if I flip-flopped those? So if I flip-flop those, then that means that it'd be friend number 2 is president and friend number 1 is vice president, right? So that's the reason why the order matters. That's the reason why this one's actually a permutation. Okay? So if I actually finished listing them out, well, I would try to organize it. So like I'm going to imagine every situation where friend number 1 is president. Okay, so friend number 1 could be president, friend number 2 would be vice president, 1 would be president, and 3 could be vice president. Another possibility would be 1 as president and 4 as vice president, and then 1 and then 5. So that's every possibility where 1 is the president. Okay, so now what if 2 is president? Well, then 1 could be vice president, 2 could be vice president, and 2 could be president, and then 3 could be vice president, and then 2 president, 4 vice president, and so on and so forth. And then I would keep matching them up every possible way. So if I did that, and I listed out all of those possibilities, this would be what I get. And then I could just count them. There would be a total of 20 possibilities. All right, let's do another one. What if I had a situation like this? It says Pizza Palace is offering a special deal on a large 2-topping pizza. If the toppings are pepperoni, sausage, onions, mushrooms, green peppers, black olives, sorry, not a fan, and hamburger, how many different types of 2-topping pizzas are possible? Well, think about again, is this one of those situations where you have different categories and you're picking one from each category? Or is it one where you're picking a small group from a larger group of things? Hopefully you figured out that you're picking a small group from a larger group because you have 2 toppings that you're picking out of however many toppings there are. Okay, and so if we count how many toppings there are, there'd be 1, 2, 3, 4, 5, 6, 7 different toppings. So you're choosing 2 toppings out of the 7 toppings that are available. Okay, and so it would be a situation number 2, and now you have to figure out, is this one where the order, if you accidentally mix up the order of what you choose of those 2 toppings, would it give you different options? So like, for instance, if I wanted a pepperoni sausage pizza, if I called up the pizza place and I said, I want a pepperoni sausage pizza, or what if I got them mixed up, I want a sausage pepperoni pizza, is that 2 different options or possibilities? And no, they're still going to put pepperoni and sausage on the pizza. So the order does not matter in this case. All right. So since the order does not matter, that means that this is a combination problem. All right. So again, I could start just like I did in the other problem to find out how many different 2-topping pizzas I can make for this. I could start listing them out. So I would try to keep it organized. Like I could have a pepperoni sausage pizza. I could have, and I'm going to match up so I can stay organized, pepperoni with everything. I could have a pepperoni onion pizza. I could have a mushroom onion pizza. Or excuse me, I said I was going to keep it organized and then I got disorganized. Goodness gracious. I could have a pepperoni mushroom pizza. I'll come back to that other one in a minute. I could have a pepperoni green pepper pizza. And then I would keep going and I'd match up pepperoni with everything. And then I would go to sausage and I would match up sausage with everything. I've already matched up with pepperoni. Okay. And so I don't have to rematch it up. So I'd have a sausage onion. Then I'd have a sausage green pepper. And then I'd have a sausage black olive. Oh, I missed my mushrooms. Oh, goodness. I'd have a sausage mushroom. So if I was organized, I'd have those flipped. And then a sausage. Where was I? Sausage, mushroom, green pepper, did onions. All right. And then black olives. And then I would keep going with sausage. And then I would keep going, matching up everything with everything else. Not matching it up more than once, because remember the order, once you pair them up, you don't have to do it again. And then if I did that, you'll notice that there would be a whole lot of options. And so if I actually listed them, that's what it looked like. and there would be a total of 21 possibilities. I just counted. All right. So that is the long way to do these problems. And so instead of having to do it that way, we are now going to talk about how you can use your calculator to do the same thing. All right. And so I'm going to go through how to do it, whether you have a calculator or whether you have Desmos. There's also websites that you can use that will help you with the stuff that we're going to do too. So if you need to call or whatever, you can call or Zoom with me and I will help you out. All right. So the next slide tells you how to do this stuff on your calculator. All right. So with the permutation and combination stuff, if you are using the calculator, so we're going to start with the calculator, all right? So if you have the calculator, and I'll zoom in just a second. Give me just a second. If you have your calculator and you are trying to do this with a calculator, then, for instance, let's say that it ended up being a permutation problem and there were 7 things to choose from, okay? So I'll create a little example here because remember, with permutations and combinations, you're choosing a small group out of a larger group, okay? So you're going to have the small group and you're going to have the large group. In these problems, you're going to see, like if you look on my slide, you're going to see an NPR and an NCR, okay? So you're going to see those 2 things. The N is actually associated with how many there are in the large group that you're pulling from. And the R in these problems is how many are in your small group. How many are you actually pulling, or how many people or things are you pulling out of the larger group, okay? And so let's say that, let's go back to my examples that I was doing a second ago. Like I was pulling 3 students out of my class. So let's say that I'm pulling 3 students out of my class, and let's say that there's 20 students in all right? So if it ended up being the permutation problem, then that means my larger group, the total number of students I'm pulling from is 20. So that would be my N. Okay. So N would be 20. Let me zoom out just a bit so you can see that. And then the R, which is the number in my small group, would be 3 because that's how many I'm pulling out of that larger group, okay? So if we were doing it like a permutation, the first thing that you do in your calculator is you type in that big number. How many total are there? All right, so I typed in a 20. Okay, and then from there, so if you just follow along with the steps here, you're going to press the math button, which is right below the alpha button. So press math, and then it's going to bring up that screen. And then you arrow over to probability, and you'll see that there's an NPR and an NCR. If it was a permutation, you would choose NPR, P for permutation. All right. So notice whenever I did that, it immediately, let me see if it'll focus. It might be too zoomed in, so I might have to zoom out just a little bit. Yeah, it immediately made that 20 a little subscript, okay? And so from there, in the next little blank, you're going to type in how many you're actually choosing, the number in that small group. And then from there, you just press enter. So if the order mattered, if it was a permutation problem, like the first person I was given $100, the next $50, and the last $25, there would be 6,840 ways I could pull those 3 people out from my class of 20 to give them their money. Okay. So now you'll notice that it would be different if it was a combination. So we'll do the combination one. So you still hit math. And then you arrow over to prob for probability because this is in the probability unit. And this time you choose NCR for combination. And then you type in, we have 20 people and we're choosing 3. And this would be the situation where I was just pulling out 3 students to help me carry something to the office. And so this would be a situation where if you switch around the order of the people that I choose, it does not give you different answers. Okay. So notice there's a whole lot less amount of possibilities because we're not changing the order to give us different answers. Okay. So if I was just choosing 3 people to go to the office for me out of my class of 20, there would be only 1,140 ways, which is still a big number, but it's not as big as the other one. Okay. And so that is how you do it on the calculator. All right. So now, what if you had to do it on Desmos, which some of you may have the Desmos app? It's very similar. So let me pull up my Desmos app real quick. It's very similar, except how you pull up the functions will be a little different. So you're going to type in, and you'll notice that it brings up that little keypad at the bottom. You're going to click on the little functions to the side, and it's going to bring up a whole plethora of options. And you're going to hit at the very top of it the stats, okay? And you'll see underneath that it has an NCR and an NPR. So that's how you pull it up. Now, when you hit it, so like if I hit the NPR, you'll notice that it actually brings it up to where you cannot type it in like you would in the calculator. So what you do instead, so like you still put the big number first. So you type the 20, but this time you have to hit that little comma that's to the side, and then you type in the number in the small group, okay? And then you close your parentheses, and then it'll give you your answer, okay? So on the Desmos, you do have to type it in a little bit different, but it's still the same idea, okay? So either way you do it, you should be able to get your answer, all right? So going back to some of those problems that we just did, you'll notice that if we go back to that problem where they were voting for a vice president and a president, if you remember, that one ended up being a permutation. So if we were doing that one as a permutation, our work for the problem, which you're going to be exhausted from the work, if you remember, there were 5 friends we were choosing from. It was a permutation. So you would put 5P for permutation. And then you were choosing 2 people. Remember, you were choosing a vice president and a president. And so that would be what you would type in. Or if it was the Desmos, it would look like this. Okay, so that would actually be your work. So if you do not have a calculator at home, as long as you write it one of 2 ways, which actually you might want to write it like this as your answer, okay? Then you will be fine, okay? If you actually have a calculator, go ahead and practice typing it in. And if you did that, you'll notice that your answer would be 20. And then with the pizza topping problem, you had 7 toppings to choose from, and you were choosing 2 to make a 2-topping pizza. So with that one, if you remember, that was a combination problem because the order didn't matter. So you'd put a 7, a C for combination, and then you were choosing 2 toppings. So that would be how you do it. And then if you did it on Desmos, it'd be NCR, and then you'd put 7, 2. And if you typed that in, you will get 21. All right. So from here, I'm going to just project some problems, and I want you to try to work through them before you see the answer. So I want you to actually pause the video with each problem, and then I will show you the answer on the next screen. All right. So this is kind of you quizzing yourself. All right. So I want you to see if you can figure out what type of problem it is and justify why you're doing it that way and actually figure it out. And then I will go to the next screen and I will show you the answer and you'll see if you're right. Okay. So use this as a quiz for yourself. So pause it so that you can work it. And then I am going to click it in just a second to show you the answer. All right. So think about what kind of problem this is. And now here's the answer. So that one would be a combination problem because the order does not matter as to who she's choosing first or second. It's going to be the same regardless, all right? And then the answer would be 105. All right, so let's do the next problem. So pause it if you need to. All right. So with this problem, the order does matter, because if you think about the way that locks work, if you accidentally mix up the order of the numbers, it won't unlock the lock. And so this one would be a permutation. And the answer would be you had, I can't remember how many numbers you had to choose from. So let me go back. You had 1, 2, 3, 4, 5. You had 5 numbers to choose from, and it was a 3-digit number. So you're choosing 3. So that'd be 5 permutation 3. And that's where the 60 came from. But if you could repeat the numbers, there is a very important thing you have to realize. Permutations only work whenever you cannot repeat numbers, okay? If you could repeat the numbers in the locker combination, like 3, 3, 4 would unlock it, where you repeated the 3, then you would actually have to do it as a fundamental counting principle problem, okay? And so if that was the case, you'd have 5 options for the first digit, 5 options for the second digit, and then 5 options for the third. So it'd be 5 times 5 times 5, which would be 125. So that one's a little different. All right. So I'm just going to project them. You pause it before I switch to the next one. All right. So there's the next problem. Pause it. See what kind of problem it is. All right. And then there's your answer. So this one would have been a permutation. Okay. And the answer should have been 30. This next one, think about it, pause it, figure out what kind of problem it is, find the answer. This one would have been a fundamental counting principle problem, because you had different categories. You're choosing one from each. And so you just multiply them and you would have got 24. All right. So congratulations. You are now a counting expert. All right. So make sure that you're studying these, because when probability gets a little harder, this will definitely help. All right. Have a great day. Let me know if you have questions.